In 1.4, we're going to be looking at compositions of functions, and we're going to start with a very abstract sense and talk about notation and how the ins and outs of it work, and then we're going to move into equations. If you've had the prerequisite for college algebra for this course, then you'll also recognize that from this course as well. So with compositions of functions, what we're going to be doing is we're going to be composing two functions together. The notation is going to look something like this. It's going to say f of g of x, and you'll notice that this little marking right here is a tiny little open circle. Sometimes it looks like bog, but it is not a multiplication sign. It is not one of those operations. It is its own symbol that you're going to see here. What this means is that we're going to take our f function, and instead of plugging in a value for x like we typically do, we're going to be plugging in an equation such as g of x for right there. Verbally, it would be f of g of x is how you might read it, or it would be read as f composed with g of x. And so when you're looking at this within your homework, you're going to see one of those two notations. Either of them can come up for you, so you've got to be able to recognize it in both formats. And so how we're going to approach this is that f is your outside function, and so I always kind of typically call this our template. This is your template, and then the g is what you're plugging in. And I'm going to say this repeatedly as we work through this section, so just know that is going to be your key detail for working through this. So first, what I want to do is I want to look at the tables and see how we can figure this out. In example 1, it says, using the tables below, evaluate f of g of 3 and g of f of 4. So we're going to kind of have to do two different situations. You can see those letters have been switched. And what we're going to do is we're going to, just like order of operation, we're going to start with the inside and work our way out. So typically you can see that this was g of x, and so they have a 3 right here. So this means we're going to first go to our table that has g of x, and we're going to look at the 3 value on x. This leads us into the value of 2. So f of g of 3 is equal to g of 3 is 2. And so now we're looking at f of 2. Now the value in the parentheses is your x, so we're going to go back over here. Now we're going to look at 2 in our f table. You can see that that leads you to a value of 8. And so when looking at a value such as this on a table, you want to start from the inside and work your way out. Don't try to stare at it and get the right number. Use a sheet of paper, work it out, go little steps at a time. You can see this goes really quickly. Not that you're working out a ton of calculations, but you've got to get your mind wrapped around where it's going. So don't just try and stare at it and get it. Take your little steps, write it down so you can visually see what's going on. Now let's look at g of f of 4. So again, I'm going to start with the inside. So right here, f of 4. That means 4 is my x on the f function. So I'm going to start here at 4. And that's going to lead us to a value of 1. So I'm going to say g of 1. Then that says that your x value is 1 on your g function. So I'm going to go here at 1. And that's going to lead me to 3. And so again, little steps at a time. You're going to see this in the homework, but if you struggle at any point, pull up a Canvas message, say, hey, I'm working in 1.4, number such and such. Can you help me out with this a little bit more? Let's go down and look at another table with this. So looking at example 2 here, it says use the table of values to evaluate each expression. So again, we're going to start with the inner part here. We're going to look at 8 as our x. So that would be 8 as our x. It says g of 8. So I'm going to go to my g function, and that gives me 4. So again, write out what you're doing. So that means now I'm going to have f of, instead of g of 8, I'll say f of 4. So now I'm going to look at 4 on my x, and that f function is at 4. So f of 4 is 4. Let's restart again. So I'm going to start with the 5 on the inside, and that's my x. So I'm going to start here with 5. G of 5 would be 8. And so I'm going to write that. F of, instead of G of 5, I'm going to say 8. And then I'm going to say 8 is now your x. So I'm going to come down here to 8 being x. And the f of 8 would be 9. And so you see, little steps at a time, they just compacted this into one table instead of writing those x values in 2 separate ones. And so f of 8 gives me 9. Now again, we're going to go from the inside out. So I am looking at 5. So I'm going to go here on 5. Let me go ahead and erase our markings here so we can start fresh. Hopefully you're following along as we go. If at any point you need a pause as you need to. So I'm going to say f of 5. So here's 5, and f of 5 is 0. So I'm going to rewrite and say g of, instead of f of 5, I'm going to put 0 here. And then I'm going to reevaluate where I'm at. I'm at g of 0. So I'm going to go to 0 on my x, and then go to my g function, which gives me 9. So put a 9 here. Let's do 2 more. And I'll just go ahead and erase as we go so we have a fresh table each time. You can see how writing this out is really helpful. So f of 3, so you start with 3 on your x and go to your f value. So that gives you 8. So I'm going to say g of 8. Then now you go to 8 on your x and go to your g function, and so you can see that that ends up with 4. One last one. We're doing f of 4, so don't get confused with the double f's going on there. And so I'm going to start with 4 on my x, and then my f, it gives me another 4. So I'm going to say this piece right here is equal to 4, so I'm going to say f of 4 is equal to, and you can see we're going to have to restart. So that would be 4, and then f of 4 is 4. So this one just keeps looping in itself, which is fine, which gives me 4. Although you think the answer is not correct, keep moving along with it. Try it out. You get 5 of 5 chances to get everything out, to get things correct. So each blank is 5 tries, then you have 5 similar answers. So 5 times 5 gives you 25. You will have many options to get these correct. I always say stop after 3 and let me help you. I want you to achieve the highest grade possibles on these practice problems or homeworks. So let's look at composition using formulas, and we're going to look at 2 different methods to help us with this. Method number 1. We're going to plug in a number and work from the inside out just like we did before. And so looking at this, it says, it given f of t equals t squared minus t and h of x equal to 3x plus 2, evaluate f of h of 1. So we're going to do it the same method, working from the inside out. So I'm first going to start with h of 1. And you can see that they have replaced x with 1. So I'm just going to pull this down. Instead of x, I'm going to put a 1 here. So it gives me 3 times 1 plus 2. 3 times 1 is 3, plus 2 gives me 5. And so now, instead of h of 1, I'm going to put a 5 here. So this would be equal to now f of 5. Where the 5 was, again, is where your t was. And so you're going to come over here and now plug in and look at f of 5. So it gives you 5 squared minus 5, which is equal to 25 minus 5. So 20. Again, we worked from the inside out, just like with the table, but this time we had to calculate, but you can see how those steps are similar. Now the next one, it's another method, is to create or compose a new function and then plug in the value. Being able to being able to create a new function is very valuable because a lot of your compositions are not going to be evaluating. It's going to be a matter of creating a new equation. So you have to know method number 2 because of the problems you're going to face. And so it says, let f of x equals x squared and let g of x equal 1 over x minus 2x. Find, look, you can see it's going to come in valuable here. Find f of g of x, find g of f of x, and then we're going to evaluate those two values. And so let's just go ahead and start with the composition of it. This goes back to the beginning of our notes. When you're looking at f of g of x, my best advice is to tell you f is going to be your template. I'm going to show you what that means in here in just a minute. And g of x is going to be what you're plugging in. So if we were looking for, we're just going to do with this part A, and we're going to find f of g of x. So the outside letter tells you your template. So what you're going to do is you're going to look at your f of x function, and you're going to rewrite it with a blank parentheses anywhere you have an x. Then if g of x is what you were plugging in, then everywhere you have a blank, you're going to plug in this g function. So I'm going to plug in 1 over x minus 2x. Now I'm not going to square that out by any means. I'm just going to leave it as is. So that right there would be my first answer of what is f of g of x. Again, I'm going to use that template plugin philosophy here. So let's do part B. Part B. I want to find g of f of x. And so again, this is going to be my template, how I'm going to set it up. And this inside part tells me what equation I'm going to use on the plugin. And so first thing I'm going to do is set up g. So I'm going to say 1 over something minus 2 times something, and I'm putting in empty parentheses everywhere I had an x. Then I'm going to take my plug-in, my f equation, and put it in all those blank parentheses. Now you do want to clean up algebraically if you can, but in both of these situations, there's not really any more that I want to do with this. Having those parentheses do not change the value of it, so I'm just going to write it without. But again, template plugin is going to be your friend as you work through this creating composition functions. Now, once you do all that legwork and you got part A and you got part B, doing the remaining part of plugging in 4 to both of them is no big deal. It's just a matter of using your calculator as you go. Reminder, you can only use scientific calculators or the calculator you see in your practice homeworks or your online homeworks. And so looking at this, we are going to have, first let's look at f of g of 4. And so f of g of 4 means I'm going to take this f of g function up here, and I'm going to plug in a 4 everywhere I had an x. So this gives me 1/4 minus 8 squared. So see, 1/4 minus 8 gives me negative 7 3/4. Or you could use your calculator again. Whenever you use your calculator, always put those fractions in parentheses and then square it. And when I square that, if you want the improper fraction, that would be negative 31 over 4 squared. And then that gives me 961 over 16, writing it as an improper fraction. I always like improper fractions. They're very exact. You don't have to worry about rounding. So when in doubt, write as a fraction. And again, your calculator can help you with that. And then part D, we want to find g of f of 4. And so I'm just going to plug in 4 into this equation we've already created. So 1 over 4 squared minus 2 times 4 squared. Now make sure we're just squaring the 4 in the second half, not 4 times 2 and then squaring it. Order of operation is important for getting the correct value. So this gives me 1 over 16 minus 4 squared is 16, so 2 times 16. So 1/16 minus 32. And that's going to give you a value of negative 511 over 16. I just used my calculator and then rewrote that as an improper fraction. So again, at the end of the day, you do need to work with the tables like we were doing at the beginning, but the bulk of your work with compositions is going to be this part up here that we were just working with AB, of creating those equations and not necessarily evaluating them. So with all this conversations of figuring out the ins and outs of them, creating them, we need to move on to some information such as the characteristics or the domain of compositions. And so when you're talking about the domain of compositions, the domain And remember, domain is something we know. It's all your possible x values. Must take into account both the inner function and the composition. I mean, you're putting pieces together, so you can't ignore one and just focus on the other. You've got to think about how this is going on. What is the inner function's domain, and how is it being comprised in that composition? So let's look at example 5. It says, let f of x equal 1 over x squared minus 1, and g of x equal the square root of x minus 2. Find the domain of f of g of x. Well, this is a multi-step problem, whether it tells you or not. I can't just stare at it and go, domain, that's what it is. I need to first figure out what's going on in the problem with my inner function. That's what we have stated here. And then 2, we also need to look at what's going on with the composition of them. So I'm going to have to compose them together. So let's take a couple different steps. 1, let's look at the domain of g of x, that inner function or that plug-in function. And you can see that looking at the domain of g of x, we've got a radical. What we know about radicals is that square root, it's never going to be negative under that square root. Or more specifically, that x minus 2 has to be greater than or equal to 0, because if we have a negative, that gives us an imaginary number, and that's not something we can work with in the real plane. And so I'm going to add 2 to both sides. So that gives me x is greater than or equal to 2. And so first, that's my domain of g of x. Second step we want to do is we want to compose them together and see what that new equation or function looks like. And remember, I'm going to use that method of this piece here is my template. And this piece here is what I'm plugging in. And so first I'm going to start with my template. So my f function is 1 over something squared minus 1. I just rewrote my f function with a blank parentheses anywhere I had an x. And then I'm going to take my g function, and that's my plug-in. And so I'm going to put square root of x minus 2 here. Now in this one, I do have some algebra I can clean up. And so this gives me 1 over the squared and the square root will cancel each other to give me x minus 2 minus 1. Combine those together, and that gives me 1 over x minus 3. So this is my combination of those functions. And so we need to not only take into the account the domain of the inner function, but take into the account the composition of them, because this is a rational function, and with it, its domain, x minus 3 cannot equal 0 because we can't have division by 0. So when we compose them together, x also can't be equal to 3. Now that we know what the inner function looks like and we know what the composition looks like, we can finish out our problem. Step 3, put it together. Told you it was a multi-step, but you didn't realize it by the instructions. You're in pre-cal, it's a sophomore level math in college, and so they're going to assume that you don't have to be given each step, that you can look at it and begin working through the pieces. So this gives me that x has to be greater than or equal to 2. And x cannot equal 3. So number line wise, if x is greater than or equal to 2, here's 0, 1, 2, 3, 4. Looking at all my possible values here, all my possible x values, that's domain. It's going to be greater than or equal to 2, but 3 cannot be there. So at 3, it's going to have an open circle. And so interval notation wise, this would be 2 to 3. And we're not going to include 3. So let me fix my notation there. So this would be a parentheses union with 3 comma infinity. And so compositions, it is relating back to what you were doing with your algebra in college algebra, but we're kind of taking it a step further with some of the domains and the tables of it. If you have any questions along the way with 1.4, feel free to reach out to me through Canvas messaging.